The question says which of the following statement about resonance energy is wrong. We have to find out wrong statement about resonance energy. Okay, there are 4 statements given here. The first statement is difference in energy of the resonance hybrid. It is including hybrid structure also, and the most stable contributing structure, okay, resonating structure having least energy. Yes, that is correct. Least energy means minimum energy is called resonance energy. That is correct, because if energy is less, stability will be higher, and we have learned higher the number of resonating structure for any species, higher is the stability. Okay, let me write it. If resonance is high for any species, its stability will also be very high. Okay, this is what we have learned. Okay, and if stability is very high, so energy of the system will be very less, because we have learned energy is inversely proportional to stability and directly proportional to reactivity. Okay, directly proportional to reactivity. If the energy is very less, then stability of the system will be very high. Okay, resonance hybrid structure is having least energy than resonating structure. Remember, because resonance hybrid is more stable. And why it is stable? Let me give one example. Pay attention carefully. We can take resonating structure as well as hybrid structure also. Okay, so in general, let's say if I talk about carbonate ion is there, so we have CO3 and it is 2 minus is there. Okay, if I draw the structure, so you can see C double O, it is what, O minus is there, this side O minus is there. Okay, this oxygen is having lone pair, it is also having, we can say 6 lone pairs are there, no sorry 3 lone pairs. Okay, we can mention, but it is not required in resonating structure. We have learned double bond, single bond, negative charge is part of conjugated system. Double bond, single bond, negative charge part of conjugated system. If the conjugated system is there, resonance will be there. Here also double, single, negative charge, resonance will be there. Okay, because it is part of conjugated system. When this electron density is moving this side, what will happen? Oxygen being more electronegative will pull the electron density. So the structure which we are getting here, you can see this oxygen is safe having negative charge. This carbon is there, it converted into single bond, oxygen having negative charge. When this electron density is coming this side, will form double bond. Okay, so now you can see this pi electron density is making movement between this carbon and oxygen. Okay, resonance is started. Again same situation, this electron density will come down this, as a result oxygen being more electronegative will pull the electron density. Okay, so as a result the next structure which we get, this is in the same as it is. In this case double bond will be there, but this oxygen will carry negative charge is there. Okay, so one time double bond here, second time double bond here, and third time double bond is here. You can see pi electron density is making movement between carbon and oxygen. Okay, between carbon and oxygen. These are the resonating structure. How many? 1, 2, 3. There are 3 resonating structure for the carbonate ion. But if we talk about the hybrid structure, so hybrid structure shows where the electron density, the path of electron density movement. Okay, so we have seen, you can see oxygen is there, here we have oxygen is there, oxygen is there, electron density is moving this way. Here also electron density is moving this side, like this. So this is can be considered, we can mention -2 charge, overall charge is what, -2. But electron density is moving carbon, carbon to oxygen, carbon to oxygen, carbon to oxygen. Okay, and one more thing is there, why it is more stable. Okay, if we talk about this structures, you can see negative charge is centralized over carbon and oxygen, no sorry, over oxygen and oxygen. But when we talk about resonating structure, this negative charge is distributed among oxygen, carbon, oxygen, oxygen, carbon and oxygen, distributed. Here only at one place negative charge is centralized. So that's why its stability in comparison to this one is less. This hybrid structure, this charge is thoroughly distributed. Okay, thoroughly distributed. That's why this hybrid structure is supposed to be more stable than this resonating structure. And we have learned in terms of energy, stability is inversely proportional to energy. If it is more stable, then energy of this system is supposed to be least. They are also stable. They are also stable, but they are not as stable as hybrid structure. So their energy is also least, but their energy is little bit higher than hybrid structure. Okay, little bit higher is there, little bit higher energy for the resonating structure is there in comparison to hybrid structure. That's why if we find the difference between the energy of resonating structure and hybrid structure, it is supposed to be minimum because they have already very small energy. So difference will be minimum, it will not be maximum. But it is talking about having highest energy. Having highest energy, that is not correct exactly. This is the wrong statement we have. Okay, if you talk about the third statement, the difference in energy of the experimental as well as calculated enthalpies, it is related to enthalpies, means this statement is given from thermodynamics. Okay, thermodynamics means oral, we can say thermochemistry also. Okay, thermochemistry, the difference in energy of the experimental and calculated enthalpies, bond enthalpies, formation or combustion of or hydrogenation is called resonance energy. That is correct. Resonance energy is equal to enthalpy, experimental enthalpy minus calculated enthalpy. This is the formula you might have learned in thermochemistry. Okay, this statement is correct. Next statement, resonance energy is the amount of energy by which a compound is stable. That is correct, because higher the resonating structure, higher the resonance, higher the stability of the compound. So resonance energy is related to stability of the compound. So in this case we have option B, which is the incorrect statement. If you like this video, please share and subscribe to the channel.